Good morning, everybody. I'm Frank Martin Seifert from the European Space Agency. We are just having a technical setup problem and hope to start in a very short time. Thanks for coming in early in the morning for the Substack day and the public holiday in Germany. I'm pleased to see you all here attending our side event. And we will talk about how Earth observation satellites support the global stocktake in the next 75 minutes. I'm coming from the European Space Agency, and let me talk you through ESA's vision related to observing the Earth. We are taking the pulse of our planet. What you see here in the background are rotating globes with data sets from essential climate variables according to GCOS, to understand the climate on our planet. You see data sets related to land, related to the atmosphere, the ocean, and the cryosphere. Within our climate change initiative, we are producing 23 ECVs out of 54 defined by GCOS. Together with the European Commission, we are realizing one of the flagships in space for Europe, which is the Copernicus system. Currently, we are having 7 Sentinels up in orbit operationally. In the radar domain, in the optical domain, altimeters, they are providing lots of information, systematic observation on our planet. Talking about systematic observation, it's not only from space, so you see a lot of space agency, it's as well agencies related to weather, universities, research centers. They are all using data and for a systematic observation of the Earth. And with this, we are contributing towards the Paris Agreement and specifically the Global Stocktake. Last year, we were submitting a synthesis report related to the role of systematic Earth observation in the Global Stocktake. That was in February 2022. And so we were addressing the GCOS, mitigation, adaptation, means of implementation, some cross-cutting issues. You can download the report from the UNFCCC portal. And today, we would like to give you an update what has happened in the last 1.5 years with respect to the systematic observation of the Earth. Observations contributing as well towards research, providing information for their assessment and policies, not only from space, as you see in the upper row, where we see a growing fleet of satellites provided by not only national or international organizations, but as well more and more by the so-called new space sector and private companies, and which gives us unprecedented possibilities to observe the Earth. But we need as well the lower row on the ground-based information, ground-based airborne data, to provide accurate estimates of weather, climate, air quality, greenhouse gases on local scales, but worldwide. And that is one of the main goals of GCOS, to increase and make these observations sustainable in the long term. From all the space agencies, we put together a portal related to the Global Stocktake. We are addressing there different observations related to greenhouse gases, above ground biomass, forest, agriculture, land cover. Here you see a recent examples, that the example of the World Cover project. It's the global land cover map in 10-meter resolution. It's we have one for 2020 and one for 2021 with 11 classes. That is currently the most accurate and detailed land cover map of the world. We are as well looking at biomass, and we just recently, a couple of weeks ago, published the 4th version of global maps of biomass from 2010, 17, 18, 19, and 20. That was done in the cooperation with JAXA, and this version 4 provides much more consistency, so we can look at a decade of change of global biomass. We are comparing as well these type of data in an international exercise called related to biomass harmonization, not to come with one single map, but to understand what are the strengths, what are the weaknesses of the individual approaches, coming up with similar type of validation activities, and providing you, the countries, best information, what is most suitable for them to use within their national determined contributions. Another one related to agriculture is provided by the World Cereal Project. And here we are addressing currently specific 4 countries, Ukraine, Brazil, Tanzania, and Canada, and providing information on maize and wheat. We are going to expand this as a global system, which can then on the fly provide this type of information for each country of the world. That's an example of the World Cereal Product Viewer related to cropland, related to maize. And that is an update from my side, European Space Agency. I'm handing now over to Martin Harold from GFZ. He will talk about AFOLU, from global maps to national reporting. And then we will continue with Carlo Bontempo from ECWMF related to the Copernicus Climate Services. And then Sara Venturini from GEO related to technology transfer and cross-cutting. And last but not least, to Lars Peter from WMO related to the Greenhouse Gas Watch project. Martin, I hand over the floor to you.
So also good morning from my side. Thanks for joining. And so my idea, and then maybe exactly put on the presentation. I'm going to talk a bit about the land use sector and AFOLU, and which is a important sector for many of us. I think it's an important sector for mitigation, but also an adaptation for many purposes. And that's where we also still know that a lot of data and observational gaps existing. When we talk about the global stocktake, the prime source of information that will go into that is, of course, that reported by the countries, naturally. And so investing in country data, investing in country capacities to provide improved estimates, in particular in the land use sector, is also an investment in the global stocktake. And global Earth observation data and products can help us to get there. I'd like to start by saying that we have, and countries have made a lot of progress in using Earth observation data to monitor their forests. Almost all tropical countries today are using free and open satellite data time series to report on their forest areas and changes. And that's a development that has been achieved over the last 10, 15 years with a good partnership between countries and international experts. At the same time, we also see a lot of investments in national forest inventories and new national forest inventory data, so these are ground-based inventories, in many of the tropical countries. So if we are now in a situation that many countries have better data now than they used to have 10, 15 years ago. This is for forests, and we know, of course, that it's a good example that progress can be made, that significant progress can be made. But we also know that going to the full land use sector, we need more than just information on forests, right? Of course, we have to talk about agricultural practices and the related greenhouse gas emissions. We have to talk about peatlands, wetlands, all these other sources. And so the question is also how Earth observation can support these other parts as well. And we are making progress. The Earth observation community is making progress. Partially, Frank Martin showed that. I think the speakers after me will also make that point. We have these coordinated observation activities coming out of the Global Climate Observing System. There's a terrestrial panel where most of the AFOLU or land use related variables are being dealt with. We do have these improved products that are coming available. So 10-meter global land cover land use is now produced on a regular basis. These kind of data can be a good base for countries, for example, to start thinking about how some of these data sets can be used, integrated, or improved using my own national data sources and capacity. So there's a good base to start from, particularly when it comes to land cover, land use, and change. But then, of course, for AFOLU, we need to basically zoom into these various broad land use and land cover types. So within forest, it's about various forest management activities. Within grasslands, we see different land management activities, different wetlands with different pools, with different drivers of change, looking into crops, different cropping practices, soils, and stuff like that. That's all part of going towards full AFOLU. And to all of these things, Earth observation can make a contribution somehow. We already saw the crop type information. There are several efforts looking into peats and mangroves. We have efforts that look into pastures and pasture degradation and the intensity of use and so on. So there is a lot of opportunity there. Things are not as operational as they are for forests, but it's quite an evolving field. And a lot of the baseline Earth observation data underpinning that are indeed free and open. How to bring it then to the country level? I would like to highlight here one activity. It's actually one of the GEO flagship activities. It's called GEO4I, the Global Forest Observation Initiative, that has actually developed over the last 15 years a really important partnership between the international expert communities, international organizations supporting capacity development, and those providing data and expertise with the countries. And I think these initiatives have been really successful, and I think thinking about expanding that towards the broader land use sector is one important area. So this is about, of course, land cover land use data. I would like to also then talk a little bit about another very important field. Also mentioned that we see an improvement now in capacities to map biomass, above ground biomass using space-based data. We have dedicated satellite missions that are built basically just for that purpose, that are either in space or upcoming in the years to come. So our capacities to improve biomass estimation from an integration of space-based and on-the-ground observation is really improving, and that creates also a lot of opportunities for countries. And I'm just going to highlight, because there's a couple of these demonstrations ongoing. For example, this is the case of Peru in the Peruvian Amazon. Peru is conducting a national forest inventory, and due to certain constraints, resources and so on, they will only be able to do a third of their plots, to measure only a third of their plots on the ground. So now they're looking to use the space-based data to basically fill in the missing observations that they weren't able to capture using ground-based data, and integrate to improve the precision and accuracy of subnational biomass estimation for their greenhouse gas inventories. And such kind of studies and working with the countries are often very country specific. There is no one-size-fits-all approach, and the technicalities as much as the capacity development activities have to go hand in hand. Also here, the Global Forest Observation Initiative is actually starting a new coordinated activity to really do that for many more countries, because there's quite some country interest to try to benefit from that, to have a common approach, to work with countries, to work with the right experts that can demonstrate the feasibility of that approach, synthesize from that experience towards improving guidance to countries and develop training materials and support the capacity development through the various international organizations. Another important development is AFOLU, and increasingly is, of course, it's about climate action, right? I mean, even in the European Union, which was the land use sector is not the biggest one, but there we see increasing pledges for climate action. Besides the tropical and subtropical countries, where in many of those the land use sector is the biggest source of emissions. So in terms of mitigation, it's a prime thing. And so if you look at the new regulation from the European Commission on land use sector, we do see, of course, a push towards higher quality estimation and reporting, so going to higher IPCC approaches, going to higher IPCC tiers. But we're also seeing a particular referral to that the greenhouse gas or information relevant for greenhouse gas inventories should also be used for policy and climate action purposes, which is what the next steps that we have to do with a lot of our greenhouse gas inventory data. So that's also now basically enshrined in new regulations that we see. And what does that mean? Policy and being policy relevant requires we need timely information, right? You can't make policy decision based on data that are years old. It needs more spatial information. You need to see where, for example, your sinks and sources, where your critical land use activities are happening, so you can understand where certain policies make sense. How can you support the implementation of this climate action with open and transparent data, and also how you track the performance of these kind of things. Right? So those are a bit different questions than we know from classical greenhouse gas inventories, but good and up-to-date Earth observation data can, of course, support that. I just give you an example. This is basically a near real-time data stream of tracking local carbon losses in a forest. As you see on your left-hand side, this is a logging operation. You see a logging road going in and tree extraction surrounding it. Here, this is shifting agriculture, so this is in the Congo Basin, right? So you see various activities, and you can track activities. That's the point. So you can track activities happening on the land, on the spatial and temporal detail that you need to actually, support, track them, enforce if needed, and so on. And this is not a local case study. This is part of pantropical efforts. So having good data on where sinks and sources are becoming available. We see first demonstration products that are now being refined, and that can also be used then to actually try to link better the global to the national. And this is just it's a map that's already now 2 years old, so there's actually been refined, but it shows the sinks and sources in the world's forest, right? So green forests are a sink, so they're taking up carbon. That's our free forest climate service that we get for free, right? And the areas where forests is a source of carbon, which is mostly due to deforestation and fires and other kinds of activities. But if you take that data, which is purely Earth observations, an integration of different Earth observation approaches, and you compare it, for example, to the data of Brazil, you get a certain estimate of the sink, of gross emissions and gross removals. And if you compare that to the national inventory, you see there's quite a difference, right, in the sink and the source. But keep in mind, you do measuring different things, right? This is all forests, everything, whereas you have to apply a national forest definition, you apply an IPCC managed land proxy, and if you do that, your estimate already gets much closer to what you get from the national inventory. And so here we can actually start to really better align estimates between these consistent global data sets versus the national data, and actually help to integrate and add up, right, whatever the countries are reporting towards the global. So with that, I would like to conclude by saying we have made important achievements in the country uptake of Earth observation data in the forest and the land use sector. There is good opportunities to enhance that, also in the broader land use sector and moving also beyond forests. It's not only about estimation and reporting for greenhouse gas inventory, but also supporting climate action with more spatially detailed and timely data. Coordinated efforts between the technical community and the country experts has proven to be quite useful and of course should continue also in the land use sector. And this also then creates more opportunities for aligning estimates from national and the global level for the global stocktake. Thank you.
Thanks a lot, Martin. And I'm handing over now to Carlo Bontempo from ECWMF.
Yeah, thank you very much, and good morning, everyone. I'm probably the one coming from the organization with the worst acronym, almost impossible to pronounce, ECNWF, which stands for European Center for Medium Range Weather Forecast. And I want to tell you a story that is technical and scientific, because that's my background, but is also, more importantly, a story of operations. Because in a sense, the climate challenge we face require climate to be taken seriously. And part of that serious approach is to ensure timely and operational production of the relevant variable. So I'm the director of the Copernicus Climate Change Service, which is one of the 6 thematic services of the Copernicus program, which is the Earth observation program of the European Union. And today is the 25th anniversary of this program, so it's also nice to talk in such a date. And what we do is really to provide operational information about the climate around us. So Frank Martin already introduced the concept of essential climate variable, the GCOS concept, so coming from the Global Climate Observing System, and mentioned the fact that there are 22, 23 of these ECVs that is possible to monitor from satellite, which is roughly 50% of the available ECVs. So on the one hand, we want to ensure that these ECVs, these variables that are so important to describe the world around us, are up to date, so that you can find a record going as far back in time as possible, but also as close to present as possible. And on the other side, we want to pick up from ESA, from our colleague at EUMETSAT, the new science, to ensure that more and more of this observation can be made available to the public. So these are about observations, and so in some cases the record goes back 20, 30 years. In some cases we can go even farther. But the offering of the Climate Change Service actually is not just about observation. It offers data about the past, the present, and the future. Climate projection, climate observations, reanalysis, seasonal prediction. And what is beautiful of the Copernicus program is that everything is open and free. So anyone can use it anywhere in the world. And this is part of the success of the program. So through the Climate Change Service, at the moment we serve roughly 200,000 users directly, globally, to whom we deliver on average 150 terabyte of data per day. And as you see, some of these variables actually are not yet well observed, and that's where the connection with science, the connection with research is particularly important. So the news of the day is about the blowing up of the dam in Ukraine and the flooding there. Well, surface hydrology is one of the things that we don't observe well from satellite, and still is so important to our everyday activity. So it's something we are working on. Another thing worth mentioning of this slide is that there are other ways in which we can gain from satellite information to provide information to our users, and it's through the use of models. So what ECNWF does is to run weather prediction model every single day. And we use these models to reconstruct the climate of the past on any place of the planet, any hour, from the 1st of January 1940 to 5 days ago. And we use it, you will use this information in a variety of ways, but probably one of the most relevant and most visible output is the State of the Climate report that we produce every year. So the 2022 edition of the European State of the Climate report was published at the end of April on Earth Day. And it contains a number of variables of relevance, but the effort is not to put those just as a variable. All the numerical values are available, but try to make sense of this for the general public. So this, as you can see in this slide, we look at a number of indicators, both global indicators and regional indicators. And it's not just temperature, it's greenhouse gases, it's glaciers, it's river, it's sea level, and so on and so forth. And this is newsworthy, because climate has become newsworthy, and there is an appetite that wasn't there before. So if you look at what has happened in 2022, and this is one of the elements that we were just mentioning before in terms of the Paris Agreement and the Global Stocktake, adaptation is a key element. And if you want to adapt to a changing climate, what you need is to have high-quality observation you can trust. So looking back at what has happened in 2022 in Europe, there were a number of striking features, including the warmest summer on record, which came just after the previous warmest summer of record, just 12 months earlier. We also had, the lowest river flow, the widest spread drought, and so on and so forth. And the ability of producing these graphs every year on a regular basis with very short delay is becoming fundamental for a number of applications, for a number of audiences. So this is the graph showing the warming of the European summer. So this is JJA, June, July, August, where you see that 2022 was almost half a degree warmer than the previous summer. And this was true for a number of variables, or a number of data sets. Here we present the reconstruction from our model, ERA5, and from ground-based observations. But it means that you can look farther. It's not just about temperature, it's about drought. And in 2022, the European drought was the most intense recorded. Some organizations call it the worst drought in the last 500 years. And struck countries that were not normally associated in our mind to drought, such as Central Europe, Holland, Germany, France, and so on and so forth. For me, one of the images that stay with me with the 2022 state of the climate is the loss of glacier ice in the European Alps that just in a single year summed up to 5 cubic kilometers, which is a colossal amount. And again, this is important. It's not just it's just a value. I mean, the visual we produce for the report, I think, is quite striking. The fact that you need to deal with this information, to design an adaptation plan that works, is fundamental, and it cannot be based on thin air. But looking at this regular report, actually we go beyond what is just the description of the climate, and we look at the elements that are becoming more important also for the mitigation effort. So if you look at the previous report, so 2021, one of the striking features was what was called the wind drought. So 2021 was a year where the wind, especially in northwestern Europe, which is the region that has the largest installed capacity of the continent, and probably one of the largest installed capacity in the world, suffer the worst wind drought in recent history. So there was no wind. And this is important, not because this undermines the investment, but because our dependency on climate fluctuation is increasing as we go towards renewable, and we need to learn how to manage it. So looking at 2022, in a sense, there is the flip side of the story. 2022 was the year with the highest sunshine, where actually the production from PV panel reaches peak, because of the high pressure that stays over the globe, over Europe for a good part of the year. And we are going beyond the climate community, we are going beyond the general public and engaging with investors. So if you look at the European Investment Bank is looking very carefully about climate information, and now climate information needs to fit into any single investment. The same is happening for the World Bank, for the Development Bank all over the globe. And working with these banks and providing the data they require is becoming fundamental. An example of it is what's happening, for instance, with IRENA, the International Renewable Energy Agency, in Africa. And they looked at the data that Copernicus produces to provide a map of where are the best locations in Africa to install solar and wind farm to maximize the return on investment. But clearly, the discussion, when you talk about climate and the changing climate and the parties here convene, the discussion is chiefly around greenhouse gases and the changes of greenhouse gases over time. So what you see here are the time series for CO2 concentration and methane, and the maps of where these concentrations are higher and lower on an annual basis. So this is done made available by the Copernicus Climate Change Service, but is also thanks to the effort made by our sister service, the CAMS, the Copernicus Atmospheric Modeling Service. And what you see here is the fact that already now, this free and open data I was mentioning allows for a monitoring of the concentration of methane and CO2 at very high resolution all over the globe. So the maps you see on the bottom left provide that. And data is available, inventory-based data is available as well on the catalog of data. And it's possible to provide inversion, so go from concentration to fluxes, although at a coarse scale. So the effort that will be expanded later on in the discussion this morning, the effort at this moment is really to use the satellite technology and the modeling technology that we have available to constrain the fluxes of greenhouse gases, so the emissions of greenhouse gases at high resolution from member states, from countries. And an example of it is not just abstract, an example of it exists already. And this is the use of CAMS data in Germany in reporting to UNFCCC. So in the German National Inventory report submitted to the UNFCCC, there are information not only coming bottom-up from the inventory, but there are information also coming top-down from satellite through inversion. And what you see there is that there is a general agreement between the two. So this, I think, is probably one of the first examples where this new technology is being used on the ground. And this is the case for Germany, but what is done in this case is not specific to Germany. The approach is generic and can be used for any country in the world. And now we can see that when you look at fluxes, and we've just talked about a follows sector, then you can start comparing the top-down and bottom-up estimate, at least on the recent period for which we have reasonable observations from satellites and from different countries. And again, you can see that while there are some differences, there are also some striking similarities between the two, especially for some countries. So I'm just want to conclude pretty much here, just to say that 2 or 3 key messages. One is that climate is such an important issue nowadays that it cannot just be left to research. The operational production of indicators and variables that are relevant for the political discussion needs to be taken as an operational task, not just as a research task. And the second element, the second take-home message is the fact that technology is mature for an inversion of the observation from satellite to get quantitative estimate of the fluxes of greenhouse gases at the global level. And this is something we are working on very much closely with WMO. So this is the work in progress that we have now to establish a CO2 monitoring and verification service. And we do expect this service to start around 2027, notwithstanding some delay in the space component of it. So thank you very much for your attention.
Thank you, Carlo. And then I hand directly over to Sarah.
Thank you, Frank Martin. And the previous speakers have already essentially prepared the ground for my presentation. I don't need to do much. Well, the input submitted to the Global Stocktake by the Earth observation community also includes chapters about adaptation, finance, capacity development, technology transfer, and other cross-cutting issues that should be considered by the countries during the Global Stocktake. I work with the Group on Earth Observations. We are an intergovernmental organization which brings together ministries, space agencies, meteorological offices, research institutions, and also private sector companies to essentially provide free access to environmental and socioeconomic data provided through measurements around the Earth. As my colleagues already implied, essentially with accurate and timely data from ground-based and space-based observations, governments can better fulfill their monitoring and reporting obligations under many global policy fora, including, of course, the UNFCCC on adaptation and mitigation, but also others, disaster risk reduction under the Sendai framework, land degradation neutrality under UNCCD, ecosystem extent indicators and nature-based solution under CBD, and other multilateral environmental agreements. Earth observation can and should be translated into products and tools that governments and local community can actually use to implement adaptation and early warning systems in various sectors, which can be then scaled up and implemented many times over in different regions of the world. And capacity development and guidance is typically provided by organizations like GEO, WMO, and others to essentially integrate Earth observation into policy and plans. And this evidence-based approach is important also for financial opportunities, because by having a stronger scientific basis of, for instance, national adaptation plans or projects with accurate historical data and future projections of climate change, then access to climate finance is also easier. For instance, GCF requires a strong climate rationale to justify its investment, and so this is much appreciated. And since a few years, we have started presenting these opportunities to the UNFCCC, a NAP Expo, which is the annual outreach event of the NAP and the LEG team. And this year, the NAP Expo was organized in Santiago, in Chile, and governments there could connect with Earth observation experts from GEO, WMO, and space agencies, and understand how to use Earth observation to develop and implement national adaptation plans. So this year at the NAP Expo, in fact, GEO and the Global Agricultural Monitoring Initiative of GEO have launched the supplementary guidance to integrate Earth observation into NAPs. It's available. It can be downloaded by anyone on the NAP Central repository. Earth observations can support adaptation in agriculture with much more timely and accurate information for food security programs and policies. And for instance, governments and agricultural agencies can essentially provide 3-month early warning to populations and farmers in case of drought affecting national crop production. And with this guidance, essentially, country can access technical assistance and capacity development to establish their own national agricultural frameworks and develop funding proposals for the Green Climate Fund. At the moment, there is, as you've heard, a huge amount of information available, of raw data that is collected and can be accessed through satellites, to ground stations, anywhere around the world. The challenge there is to access, first of all, to high-resolution data, and second of all, understanding these large volumes of Earth observation data, particularly in developing countries where resources are limited and maybe connectivity is poor or unreliable. So at GEO, we promote collaborations between public and private satellite data providers and governments to enhance this observation data collection and access by the experts that need it. We also bring together global technology providers and geospatial players to essentially help developing countries with free licenses and grants to run their projects without the need of physical IT infrastructure. And as we complete the first 2 decades of GEO, public-private partnership figure more and more in our mandate. And some examples of these collaborations are the 60 cloud credit projects that we launched over the past few years, addressing climate action, disaster risk reduction, and sustainable development in over 60 countries, including LDCs and other developing countries. And these projects are funded in collaboration with these global technology providers, such as Amazon Web Services, Google Earth Engine, Microsoft Planetary Computer, and we have dedicated programs providing free licenses and grants and technical and financial support following a competitive call for proposals. And these programs also give access to additional software capabilities, for instance, provided by Esri, and collaboration with commercial satellite companies like Planet or Maxar or others that provide very high resolution imagery, like up to 15 centimeters, that are not normally available for free. And some examples of these collaborations are happening already in many countries. In Costa Rica, the Ministry of Environment and Energy is using Earth observation essentially to create, test, and improve models that use essential biodiversity variables, the sisters of the essential climate variables, to predict ecosystem services and assess the value of those services. The goal really here is to identify and map essential life support areas and develop nature-based solutions. In Ecuador, the GeoGLOS streamflow service provided by ECMWF is producing global runoff forecasts for every river in the world, and is being customized in Ecuador and many other countries in Latin America and Central America. And it is accessible online with a user-friendly interface. Essentially, the system is easy to use and augments the forecasting capabilities of national meteorological offices significantly. Essentially, a Met Office can now, with this system, predict floods up to 15 days ahead of the extreme event, instead of the typical 3 to 6 hours early warning, which is a huge difference for when it comes to preparedness and impact on population. In another example, in Togo, NASA and Planck came together under our GeoGLAM initiative, essentially to support mapping a nationwide cropland map that would support a loan program. Essentially, during COVID shutdowns, the agricultural production was, of course, constrained, and the government needed to identify the farmers to provide this support. But in the past, this data was only available using Togo's census data, but this census data didn't really map for all the informal smallholders who rely on subsistence farming, who will really need to be the target of this program. But with the Planck high-resolution imagery and the NASA harvest team, essentially were able to develop this cropland map for Togo within 10 days. And this satellite data essentially filled the gaps in the census data and enabled the distribution of these loans in an effective way. In addition, the government overlaid this map with poverty maps developed in collaboration with Berkeley University, and together, essentially, they provide really important information for poverty protection policies and for mapping the needs of rural communities. So, in summary, important achievements have been made on using Earth observation for adaptation, and many technology transfer initiatives are in place to support countries' capacities to monitor and report climate change, but also to implement action on the ground. And I'll be available for further information, of course. Thank you.
Thank you, Sarah. And I'm handing now over to Lars Peter from WMO.
Thank you. Thank you very much, Frank Martin. Good morning, everybody. So we've heard a bit about bottom-up estimation of various climate variables from Frank Martin, from Martin, and from Sarah. I want to pick up perhaps more along the lines of what Carla was talking about. Why do we need to move some of this estimation or these activities out of research and bring a more operational flavor to it? I'm going to be talking about greenhouse gas flux estimation. So it's actually quite complementary to what Martin was speaking about, but I will come at it from the top-down angle as a complement to the bottom-up estimation that has sort of been the dominant thread in most of the activities of UNFCCC and also of the IPCC, too many C's. So I'll be talking about the WMO Global Greenhouse Gas Watch, which is a new initiative that was just approved by the WMO Congress a couple of weeks ago. And we've been preparing for this for about a year and a half with a lot of people that are listed here. You probably can't read that, but a lot of people from both the research and operational communities have been engaging in this. So why is WMO embarking on this new initiative? Let's start to look at what are the particular problems that we're trying to address here. And there's two parts to the problem statement. We all know what the Paris Agreement is and why it was adopted. That's why we're here. We're trying to limit climate change, and the tool that we have in our hands to do that is to reduce the net anthropogenic greenhouse gas emissions. It's a very easy statement to make, but it's not easy to implement, obviously. It's actually not even easy to say from a scientific point of view exactly what should you do. The first problem is that Paris focuses squarely on improving the estimation of anthropogenic greenhouse gas emissions. That's fine. I mean, that is the tool that we have in our hands to manage this problem if we can agree how to do it. What is often lost in the discussion is that we are not the only ones who contribute greenhouse gases. Nature pumps into the atmosphere and takes out of the atmosphere much more greenhouse gas than we do on an annual basis. So for the last, at least for the last 10,000, actually to some extent for the last a couple of million years, what nature put into the atmosphere and what it took out were largely in balance, so the greenhouse gas concentrations have stayed somewhat constant, at least over the last 800,000 years. They varied within a fairly narrow band. That's no longer the case. What we are doing to the atmosphere has perturbed that balance. So the natural fluxes react both to our emissions and to the climate change that we have induced. And if we don't take that into account, if we don't understand that, then we are, in engineering terms, operating a control system where we don't understand the link between the control and the output. Any engineer will tell you that is not a good idea. So we need to understand that a bit better. The second problem is that the way we talk about this, emissions can be both positive and negative. The positive emissions are the negative ones, the one we want to avoid. So that's a little bit like a positive test in medical terms is something that you typically don't want to see. So positive emissions are what we put into the atmosphere. We understand those quite well. We largely, to the extent that they are driven by fossil fuel consumption, we have fairly good data on how much coal, oil, and gas we dig out of the ground. We know what it leads to when it's burned. All of it is eventually burned, is the assumption. So far, so good. Those are the positive emissions. The negative emissions are what we take up by afforestation, curbing forest degradation, changing agricultural practices, etc. The accounting for negative emissions are a lot more problematic. They're poorly regulated, they are not effectively monitored, and the result of that, I mean, you all read the press, there's a lot of bad press around things like carbon credit trading and carbon offsetting. Not just in the climate change newsletters, it has spread to the financial press and to the mainstream press as well. So the risks of this, the lack of monitoring and regulation are well documented. There's a risk of overestimating the impact of double counting or triple counting, perhaps, etc. So that's not good. It's important to remember that to some extent, emissions is a human bookkeeping exercise. The climate doesn't actually care about that. The only thing climate responds to is how much greenhouse gas is in the atmosphere, not who claims how much they put into the atmosphere, how much they took out of it. And what is in the atmosphere is well documented. This is the Mauna Loa growth curve. 60 years of sort of slowly accelerating growth of CO2 concentrations. And you can amuse yourself by putting the timelines of the big climate agreements in there. We have Rio, we have Kyoto, we have Paris. And one way to speak to this graph here is that maybe we're not understanding this problem correctly, at least what we claim to be doing. I mean, we're all carbon neutral, either carbon neutral or we are on the path to becoming carbon neutral. There's something that is not right, because if that were true, then this curve shouldn't be going the way it is going. So if we just stick with CO2 for a minute here, how well do we actually understand the CO2 fluxes? This is a graphic from the Global Carbon Project that puts out this phenomenal set of data every year on what is going on with CO2 and methane, and now they are also doing N2O and a couple of other things. The top level of it we actually understand quite well. So I don't know whether you can, yeah, you may be able to see it. So on the left-hand side, the green blurb there, we have the total emissions that, as I explained, we understand quite well. We understand very well how much of it is hanging around in the atmosphere. That's the red stuff in the middle. So the rest of it, the difference between the left-hand and the central number is the number on the right-hand side. Those are the sinks. I mean, it's not in the atmosphere anymore, so it must be going somewhere. At that level, we understand it very well. Then our understanding gets a little bit more shaky when you get into the detail. We think that about half of the sinks are on the land surface, half of them are in the ocean, but we don't know too much about the ocean in particular. When, where, and why, and for how long will it continue? What we know about the land sink, I think Frank Martin and Martin explained a lot more about that than I need to go into here. But the bottom line of it is that the natural sinks, the sum of the natural sinks are well known, but there are uncertainties about the distribution between the two main components, and there are a lot of uncertainties about, when you go down to a more granular level, about where exactly is this happening. On the land use change, there are very large relative uncertainties, close to 50%. There's not that much uncertainty about the fossil fuel consumption contribution. That is actually the best documented of the whole thing. So the bottom line here is that focusing our efforts only on what we already understand well is not going to be good enough to compel parties to take the action that they need to take. There are two ways to look at greenhouse gas concentration and why they change, and I'm not sniping at anyone in particular. Both will be needed. So first up, bottom-up estimation. This is the kind of thing that Martin and Frank Martin were talking about. The idea of bottom-up is that you take everything you know or you think you know about activities or things that contribute or subtract greenhouse gases from the atmosphere. So the planes, the cars, the cows, the forest, the smokestacks, etc. And you add it all up and you try to infer what might that do or what might that have done to the atmospheric greenhouse gas concentrations. This is very good for anthropogenic emissions. It gives you mostly bulk national data only, and it tends to do it with a bit of delay because it relies on economic data and activity data for the anthropogenic emissions. It doesn't work that well in developing countries often because you don't have the data available there to do this. It is not applicable to most natural sources and sinks because nature doesn't report. There are things that you can do with Earth observation data on the above-ground biomass estimation, but there are things that are really difficult to do also for natural sources and sinks. Almost everything that is happening or that has happened in the Paris Agreement so far has been based primarily on bottom-up estimation. The logic in top-down estimation, at least in the context that I'll be talking about it here, or that I'm talking about it here, is if you want to know what is happening in the atmosphere, look at the atmosphere. Don't just look at the trees and the cars and all the things that are contributing or subtracting. Actually, look at the atmosphere. Look at what is happening there. So the idea in this form of top-down estimation is to use atmospheric observations in conjunction with atmospheric models and try to figure out exactly when and where do greenhouse gases enter or exit the atmosphere. I have a cartoon slide coming up that explains the methodology. It's conceptually very simple. It is algorithmically and technically atrociously complicated, like many other things, but the concept is simple. The beauty of it is that you can do this, you can integrate it over the entire planet, and you can integrate it over time, so it can be linked directly to the atmospheric growth curve. If your bottom-up flux estimation doesn't add up to the growth curve, then you're doing something wrong. It gives you global coverage of fluxes. It can be spatially disaggregated, but it gives you net fluxes. So for every grid box on the planet, you get the net flux in or out. It doesn't tell you who's at fault or who's being the good guys or the bad guys here. Net fluxes. It can be done in near real time, and the technology for this is mature. Carlo explained it. He gave an example of top-down flux estimation, namely the Copernicus Atmospheric Monitoring Service. So it's coming. It is not yet present, very present in the discussion in a forum like this, but it is coming. The reason why we started talking about this in WMO a year and a half or so ago is that the global infrastructure that you need in order to do top-down flux estimation is very similar to the weather prediction and climate monitoring infrastructure that our 200 member states or 200 or so member states have been coordinating through WMO for the last 60 years. So, just a quick illustration of how it works at the local level. Let's imagine that you have a forest and you want to estimate what is my forest doing to the atmospheric CO2 concentration. You could measure all the trees, you could count them, try to figure out how much carbon is stored there, and you could come back a year later and you could do the same thing, and you say, okay, there's either more or less carbon than there was a year ago, and the rest must have gone into the atmosphere. That's bottom up. Top down is you put some CO2 measurement equipment around your forest, and you measure the meteorological variable as well. And then conceptually, on a given day, you might have one value, 420 ppm on one side of the forest and 418 on the other side. You can then, and you know the wind field on this particular day, you can then set up and solve a very simple equation that tells you what must the flux have been over the forest in order for these measurements to make sense. That's at the local level. If you want to do it globally, you basically do more of the same. You take the globe and you divide it into a few 100,000 or a few million grid cells, depending on how big a computer you have. Then you need some measurement equipment. You need a lot of measurement equipment, and now you need satellite data as well. And then you superimpose what you know about the atmospheric flow on these observations, and you do the same thing again. But instead of a simple equation, you now have a humongous set of matrix equations that you solve, and that will give you an estimate of the flux in every single grid cell across the planet. This is conceptually very, very simple, it's not simple, it's very similar to what you do for numerical weather prediction. It is actually to some extent the same model. So the building blocks for this already exist, but we do not have an integrated global system that runs operationally and does what I just described here. And I want to dwell on that statement just for a little bit. We don't have an integrated global system that runs the way weather prediction and climate analysis is done. Why not? Because so far greenhouse gas monitoring is undertaken in research mode. So it's funded by research funding and by researchers and not operationally. I don't want to diminish the effort. This has led to a phenomenal amount of insight, but there are certain things that research efforts cannot do. They cannot guarantee a sustained operational observing system. They cannot deploy a truly global observing system, and they cannot set up typically near real-time exchange of data. In order to constrain this problem with observations, we need more observations than we have. That's one of the problems. On the left-hand side here at the bottom, you can see what we have on the ground in terms of weather stations. On the right-hand side, you can't see much, but this is what we have in terms of greenhouse gases. So that's a problem. In the interest of time, I will skip over what we have on the ocean. We have almost nothing, so that's quick work. So when we started talking about this system, we had a symposium in the WMO building a few months ago on greenhouse gas monitoring, where it was open to the entire research community, and we had a couple of hundred people with us in the building, an additional 500 online. A lot of energy, a lot of discussion, a lot of interesting presentations. And this symposium came out with a consensus statement, which was a clear and unequivocal call for WMO to take the lead and actually develop an operational context for this system, very much in line with what Carlo was mentioning before. If you want to take action on something, you need an operational context to do that. We don't do, weather prediction has been a phenomenally interesting and difficult research problem, and it still is. But we don't do weather prediction as a research activity. It needs to be running around the clock. It needs to run also on Christmas Eve and when people are on vacation and all this kind of stuff. So it requires a completely different mindset. And so does greenhouse gas monitoring if we want this to be actionable. So WMO has been developing the concept for an operational system over the last year and a half. And I don't want to, in the interest of time, I don't want to run through all the bullets here. I just want to speak to the blue box here. In order for this to be actionable by the parties to the convention, it is extremely important that this be conducted openly. So all modeling centers that are interested in this have to be able to participate. It needs to be done transparently with free and unrestricted access to all input and output data, and preferably using documented methodology. So Carlo gave an example. The European Commission is doing this, or is about to do this via CAMS, which is good. But it is not good enough because CAMS is fully funded and managed and owned by one group of members, namely the European Commission. They may be however good they are, but it is unthinkable that, for instance, the US or China or Russia or India would let their mitigation activities be driven by something that they have no access to, that they don't control. So for that reason, it is really for that reason that WMO is setting up this context where CAMS can play along with anybody else who is doing this around the globe. And I'm not sniping at Copernicus here. They were actually among the first ones to ask WMO to do this, because they're expecting that the other big economic and political blocs will do this. I'm almost at the end here. So this was the rationale. This is about what we have been proposing, and it was just approved by the WMO Congress a couple of weeks ago. Actually 2 weeks ago, yesterday. So we are now on the hook to develop a costed implementation plan for this, and these are some of the activities that we're planning here over the next year. Workshops with the operational entities that can do modeling and assimilation, and an open workshop on the greenhouse gas observations, mostly focused on the surface-based side. The satellite agencies are very good global citizens. I mean, they make measurements. They normally make them available to everybody. The surface-based side is a complete uncoordinated mess. I mean, I don't know how to say this politely, but that is what it is at this point in time. I showed you very few greenhouse gas measurement stations because that is what we see globally. We know that there are many, many national programs and individual research activities where greenhouse gas measurements are being made, but they are not exchanged internationally. So from our perspective, this is really a wasted opportunity in terms of making these data actionable. And this is not a criticism of the people who are making these measurements, because we have not so far provided them a framework and asked them, would you be willing to exchange your data? But now we are, and now we want to engage in the conversation with them. And we are also engaging with the private sector. There are many private sector entities who are extremely interested in participating with us for reasons that are sometimes a bit surprising to me. There are entities with hundreds of millions of dollars invested in carbon credits, for instance, and they are worried about, okay, where's my money, what's happening to it? And they want to talk to us as well and see could this help shore up the carbon market, and many other interesting activities. Thank you very much, and apologies for speaking so long.
Thanks a lot, Peter. Well, you heard now about the update of systematic observation community related to space agencies, CEOs in the airflow sector, on operational climate change services from within the Copernicus system, agriculture, food security, partnerships within GEO, and the last one on the development of an operational global system for greenhouse gas monitoring. There are many more updates which we could not take into account for this event. They are combining space and ground data with modeling. They're moving from science towards operational observations. Most of them are available openly, and they provide an increasing transparency of the information. We are looking at global aspects and as well to support national reporting towards the global stocktake. And now the floor is open for your questions.
Hello. Oh, thank you very much. That was an incredibly interesting panel. I'm studying my master's in environmental law. I really enjoyed the double meaning of the top-down framing of satellite observations. I really enjoyed that. You spoke about the need to include other parties and interested parties, and I was interested what capacity benefit sharing and technology transfer programs are in place for parties which might want to become interested parties but don't have the resources. So how can we operationalize the principle of equity in participation, so not just in the sharing of data, but transparency in operationalizing and ownership of the satellites? Thank you.
Second one.
Thank you. My name is Mark Roelsma, PBL, Netherlands Environmental Assessment Agency. I also think it's very exciting because this is really what we need in the near future. But I was wondering, especially a lot of things were about land use and forestry, but to what extent is it possible, or is it already being done, to use these satellites reporting for cities or companies? And that would be, at least for me, very interesting, I think. Thanks.
Yeah, so in view of the challenge of bottom-up data in developing countries, what could be done to improve that?
So the first one on capacity development, this is this is a very good question and a very tough one, actually. On what I was speaking to on the modeling side, the capacities reside pretty much in the entities that I mentioned. Some of them are, a couple of them are formerly developing countries, but they are among the more affluent one. There are two areas of capacity development that are incredibly important. One of them, I think, was also what was mentioned in the last question, deploying observing systems in developing countries. In order to have a truly global observing system, we need the developing countries, because those are 2/3 of the countries on the planet. And in WMO, we know how to do this, actually. We have capacity development and financial mechanisms to support this. We are getting very good at that with weather stations, and we need to take some of that approach and transfer it to greenhouse gas observing stations as well. And the other element is capacity development at the government level, so they can actually be be stronger as negotiators in a forum like this. This is a little bit outside WMO's core remit, I think, but I very much recognize the need for the two to go hand in hand. And I think the second question is probably for somebody else.
Yeah, well, I think it touches on more than one question, and in the sense that for me, one of the limiting factor is so if we want to have this more equitable approach to the tools and the solution, I think the first step is to make the data freely available and accessible. So that's the step one. Notwithstanding what the final goal might be, that needs to be step one. The second one, which is still achievable, is to make some of the processing also transparent and openly available. So in a sense, filling the gap with the satellite technology that may take longer and may not be achieved in the near future. But filling the gap on the processing and the know-how on how to process the data, that's achievable. And in that sense, while I take completely the point that a single entity developing a top-down mechanism may be politically unsuitable, having the full sequence of steps that are required to transform a satellite data set into a service, all transparent and open and processable on the cloud, I think this is a step towards democratization of the process and so towards equity. It's not the final goal, but it's a step in the right direction. Thank you.
Yes, if I may add,
Yeah.
in terms of capacity development, I think there could be a role for GEO there, because we have this connection with the countries, boots on the ground, as you say. And I would really think that there is the need to build trust for countries to be able to accept this information coming from a sort of third party and integrate it into their inventories, into their reporting mechanisms. So it's a long process, but it needs to start and stakeholders need to be integrated in the early stages of the development of this project, which is already essentially foreseen by WMO and the partners. Also, in terms of access to data, as Carlos said, it's important to have free access, and all these new emerging satellite companies that have very high resolution data, they normally come with the price tag, and there's need to identify innovative mechanisms to get access to this data. I can give you an example. The government of Norway has funded a multi-year program by which the licenses from Planet and other private satellite companies are bought by Norway and provided for free to any users around the world who wants to have access to information on tropical forests for deforestation monitoring. And so this can be replicated and scaled up at the global level, and information can be provided not only on deforestation, obviously on everything, on carbon, on adaptation, and so on. And the third point about private sector, definitely there is a lot of interest by companies, corporates, private and public banking institutions to get more timely, more accurate information, especially from satellites, about climate, about ecosystems, because there are reporting obligations that are emerging for them too. There are global initiatives like the Task Force on Climate-Related Financial Disclosures, Task Force on Nature-Related Financial Disclosure, that essentially are going to do that, are going to, with the involvement of these stakeholders, develop the frameworks under which they will have to report. And to do that, they need the data. And so we are already working with them. There are initiatives ongoing, but at the moment it's still sort of in the initial stages. Yeah.
Well, capacity building is as well not only a topic within individual organization, it is as well related. There are bodies who are trying to coordinate capacity building over larger institutions, and to provide better capacity building service towards developing countries. The question related to urban, of course, there are many urban applications. You see urban expansion of urban areas, urban footprints, urban heat islands. As I said before, we cannot report within 75 minutes on all types of new and available data sets and information services. But for sure, it's not forgotten. Was there? Did we forget? I think we are close to the...
Let's take these last two.
You had already one. There's one in the back.
So close.
Hi, I have a question for the last speaker. I wanted to ask how the top-down approach, you said like the bottom-up approach is good for anthropogenic emissions, but how well does that work for the top-down approach? In the bottom-up approach, we have this scope 1, 2, and 3 emissions, and you already said that some countries wouldn't be huge fans of the implementation of the system, which makes sense that if you then see high emissions in some countries which produce a lot of products which are then used in the global north, and yeah, you wouldn't have that reflected in a top-down approach. So I'm interested to hear your ideas on that.
Lars Peter, short answer.
Did I really say that there are countries who are not fans of this? It's true, though, but I don't think I said that. It was unanimously adopted by the 193 WMO members. It's not about anthropogenic emissions yet. I mean, the Global Greenhouse Gas Watch will make the data available, and then it is for parties to decide how to use the data. Initially, we will do this at 100 by 100 kilometer grid scale. So it'll tell you what's happening over the big areas. And of course, you can integrate all over countries also, and then you can make whatever conclusions you want out of that. We will be able to do this at 1 by 1 kilometer, and then you will start to be able to see, okay, this is nature, this is not nature, this is nature, this is not nature, etc. Initially, CO2, methane, and nitrous oxide. Once we get co-emitted species like CO, maybe isotope measurements, then you can start distinguishing between where does it come from. But in the initial go-around, it's really more about the geographical nature of the information.
Thanks a lot. Thanks a lot for coming and joining this side event. Let's give a final applause to the panel. We will be all available for the next 10-15 minutes for further questions outside, but we have to leave the room now and to free it for the next side event. Thanks a lot.